Hello students, welcome to another chemistry class. I congratulate those that did the assignment and submitted. If you know you did not do your own, keep doing the assignment. That's the only way to improve. Subscribe to the channel so that you can get updates whenever class is posted. The channel is still www.youtube.com/@SarUgoEducational. So subscribe so that you get the update. Today we are looking at chemistry. From where we stopped in the last class, we discussed everything concerning the first 20 elements, their groups, and what have you. Now we are talking about chemical combination. You know that elements go into reaction because they want to achieve the octet configuration. What do we mean by octet configuration? That is having 8 electrons in their outermost shell. That is what makes elements to go into reaction. So those elements that already have the octet configuration, the noble gases, they do not react. If you can recall, that those are the elements I told you that they are group 0, or you call them group 8. They do not react. So other elements that are not in that group, from group 1 to group 7, they react in order to achieve that state, which we call the octet configuration. Okay, so in chemical reaction, we mean a combination of elements chemically, and that's what we call chemical combination, when they combine chemically to form a compound. Now, under chemical combination, there are three major chemical combinations. There are other ones, but the three major ones are electrovalent combination, covalent combination, and coordinate covalent combination. Today we'll be treating covalent combination, and from what we have here, we say this is a type of combination in which there is transfer of electron from a positive element, usually metals, to a negative element, usually non-metals. It is otherwise called ionic bonding. An element gives out electron and another accepts. So it's a give and take situation. The metals give out electron. Remember from our last class, I said metals are the ones that have either 1, 2, or 3 in their outermost shell. They give out electron, while the non-metals accept the electron. When this happens, we say it is an ionic or electrovalent combination. So, and once they give out the electron, they form ion, both the metal and the non-metal. The metal form a positive ion, and the non-metal form a negative ion. So we are going to consider some examples here. Example 1, the reaction between magnesium and oxygen to form magnesium oxide. The atomic number of magnesium is 12. And from what we discussed in the last class, the 12 means 282. Those of you that participated in the last class or have viewed the video, you know what I'm talking about. To be 282, that means 2 filling the innermost shell, 8 filling the second shell, and then 2 at the outermost shell. That is this 282. Whereas oxygen is 26. Now, if you can see, you see that this one has 2 in the outermost shell, and this one has 6 in the outermost shell, which means that none of them has attained the octet configuration, and that is why they are reacting. So when they want to react, this is the structure of magnesium. See the 2, 8, and then 2. So magnesium wants to achieve 8 electrons in the outermost shell, and it's not possible for magnesium to receive 6 electrons, because that one that has 6 electrons just need only 2 in order to achieve the configuration. So magnesium is bound to give out electron. It cannot receive, because if it wants to receive, it will receive 6, and no element is willing to give out 6. The element that has 6 just need only 2 to attain the octet configuration. So just like oxygen. Oxygen has 6 in the outermost shell. That's atomic number is 8, 2 in the innermost shell, and then 2, 4, and 6. So with this now, you see oxygen needs only 2 in order to have 8 electrons in the outermost shell. And for oxygen to react, oxygen will be waiting for an element to give it an electron to complete this. So oxygen cannot give out these 6. Rather, it will receive while magnesium cannot receive, rather it can only give out. So in this reaction now, you see magnesium gives out to this oxygen, this electron goes to this one, see the arrow, goes to this one, and this one goes to this one. So if you watch now, you see that once magnesium has given out these two, this shell disappears and magnesium remains 2,8. That means this 2 has been given out. Now, for oxygen, these 2 electrons have received 1, 1 each. And as they have received 1, 1 each, that means that they now have, oxygen now have 8 in the outermost shell. So both of them are okay. This one has 8 in the outermost shell, and this one has 8 in the outermost shell, forming magnesium oxide. Example 2, when you have potassium reacting with sulfur, atomic number of potassium is 19, and that means 2881. Sulfur is 16, that is 286. When they want to react, now potassium has only 1 electron in the outermost shell, that's this one now. Okay, so when it wants to react with sulfur, sulfur needing 2 will not accept the reaction with only 1 potassium because it has only 1 to give out. So giving out 1 to sulfur will not solve sulfur's problem, but may solve potassium's problem. So sulfur will not agree to that. Sulfur will tell potassium to bring a second brother. So that's why you see you have 2 potassiums, this potassium atom and this potassium atom. Now, 1 gives out to this and 1 gives out to this. In such a way, this one now, the shell goes out and it remains 288. The same thing for this one, it will remain 288 because this shell will go out after giving out this one. And it means that this one now, this sulfur has received 1 here, and this one also received 1 here. In other words, for the reaction to happen, there must be 2 potassium atoms and 1 sulfur atom. And that is why we write potassium sulfide in this way. We write it as K2S, meaning that 2 potassium atoms combine with 1 sulfur atom to form potassium sulfide. So this is what we call electrovalent combination. And now I will want you to try other electrovalent combination in this form. So your assignment is going to be reaction between aluminium and chlorine. Write a chemical equation for the reaction between aluminium and chlorine. Show it in this form, the way that I have shown my own. How do they combine? That one is also an electrovalent combination, so that will be your assignment. Thank you. So this is your assignment. Write a chemical equation showing the reaction of aluminium with chlorine. Show the illustration. What I mean is the same way I have shown the transfer of electron, the one giving out and the one receiving. Do it that way. Thank you very much. See you in the next chemistry class.